All right, so I'm going to do an example that deals with a small sample, and we're going to do a confidence interval, and this is going to be quantitative data, so we're looking for a small sample for the mean, which means we'll use a t-distribution. All right, so I'll go over this example and show you how to do it on the calculator. All right, so our question reads, we start with a simple random sample of 25 of a particular species of newts and measure their tails. The mean length of our sample is 5 centimeters. We're also assuming that the tail lengths are normally distributed. So we need either normal distribution, getting our data from a normal distribution, or something approximately normal in order to use the t-distribution for a small sample size. So the pieces of information that we have, right now, we have n is 25, and we have x bar is equal to 5. That's our given information up at the top. Okay, so let's take a look at problem 1 here. If we know that 0.2 centimeters is the standard deviation of the tail lengths of all newts in the population, then what is a 90% confidence interval for the mean tail lengths of all newts in the population? So the piece of information that we're given here, well, we're given, I guess, a couple. So we're given that sigma equals 0.2. That's what this part is. And that's because it's standard deviation of all tail lengths of all newts in the population. So we use sigma because sigma is our population standard deviation. Now we want a 90% confidence interval for the mean tail lengths. Our formula for that, and we're not going to use the formula, I'll fill some stuff in, but we'll use a calculator. So x bar plus or minus t of alpha over 2. And we have sigma, so we'll use sigma over square root of n. The t of alpha over 2 will either need a chart or a calculator, so our calculator will do it all for us. I'll fill in the stuff that we have. X bar is 5. We have alpha. Since we're dealing with 90%, that means our alpha is going to be equal to 0.1, and alpha over 2 is 0.05. So this is going to be t of 0.05, and then our sigma is 0.2, and square root of 25 is 5, but we'll just do that. Let's write that a little bit bigger. Okay. But again, this is the formula, and we could use a chart for to find the t, but we are going to use a calculator instead, and it's just going to give us the entire answer as an interval in interval notation. So this is an emulator for a TI-84, and let's turn it on. Okay, so the way to get into the calculator function that we need, we have to hit the stat button. So we've used the area calc to do our 1var stats. We don't want that. We're going to go over to the tests and look for the appropriately named test or interval of use. So there's a couple things about this. Anywhere we see the word test, that's going to be a test hypothesis. We don't want that. We want something that says either the word interval, like you see number 7 says z interval, or something that says int, which is partial word for interval. Now we actually want 8. If you notice, like 9 and 10 have the partial word int. Those are also intervals. Those just are wanting 2 samples. So number 8 is the one we're going to choose, t interval. Okay, so there's 2 methods that we can use this calculator function. We can either enter data into a list and tell it the list. In this case, I've got list 1 set up there on the screen. But we don't have any data here. All we have are summary statistics. So I'm going to arrow over to stats and hit enter. Now we're going to tell it everything and ask for. All right, so X bar, we have that. It's actually behind the emulator. Let me move it down. We have X bar is 5, and then N is 25. So X bar is 5. We don't have S of X. Typically, when we're doing a confidence interval for a small sample, we're going to use S. We don't have S here. We only have sigma. And if you have sigma, sigma is certainly better. Remember, S is just an approximation for sigma. So we're going to use sigma, and in this case, it's going to be 0.2. N, in this case, is 25. And our C level stands for our confidence level. We want 90%, so 0.9 is what we want. Don't put in 95. That's going to be bad. All right, so this is how your display should look at this point for this problem. T interval up top, we're doing summary stats. X bar is 5. S is actually sigma, and it's 0.2. N is 25, and our confidence level is 0.9. So we hit calculate, and we get an interval. So our interval, so a low amount, that didn't go well. So our low amount is, we'll call it 4.93, and our high amount is 5.07 with rounding. So 4.93 to 5.07. So that interval here is our confidence interval for this problem. All right, let's take a look at the second problem and see what changes have been made. All right, so number 2, if we don't know the standard deviation of all tail lengths of all newts of the population, but our sample has a standard deviation of 0.4 centimeters, then what is a 95% confidence interval for the mean tail length of all newts in the population? All right, so here instead of sigma, we have S, but S is okay. So S equals 0.4, and we have 95%, which means our alpha level is 0.05, and alpha divided by 2 equals 0.025. And remember, for these are the areas we're looking at here. This is, well, I guess it's T, not Z, excuse me. This point here is T of alpha over 2, and this one is actually negative T of alpha over 2. But it doesn't matter which one you put in, because since you're adding and subtracting, if you add a negative, it's a subtraction. If you subtract negative, it's addition. So you're still going to get the same two values. So this area here is alpha over 2. This area here is alpha over 2, and that equals 0.025 and 0.025. So we have the same situation as we did above. The only change that we have here in our inputs for the formula, we're going to have, so we have 5 plus or minus T of this case is 0.025 or 0.975 if you prefer. We don't have sigma, but we have S, which is again an estimate, which is 0.4 this time, and our N is still 25. Okay, so that's what we have, and let's see what we can do here with the calculator. All right, so we're going to go back into the same spot. We hit the stat button, and then we arrow over to tests, and we go down to the T interval. All right, so if you notice, all of the same information that I had a moment ago is still there, and the calculator will save your last stuff in the same thing, in whatever function you're using. All right, so X bar remains the same at 5. S, and we're using S this time, is actually 0.4, not 0.2. N remains 25, but the confidence level changes to 0.95. And we will calculate this now. All right, so now our interval goes from 4.83 to 5.17 with rounding. So let's do that. 4.83 to 5.17. Mm-hmm. 4.83 to 5.17, excuse me. Having problems with my eraser. There we go. So 4.83 to 5.17. So this is our 95% confidence interval for the mean X bar. And this was a 90% confidence interval. And this is how we do a small sample confidence interval for a mean using the calculator that you'll have in class.